wouldn't it be lovely to make contact with another civilization that has arisen and evolved independently? Well, one thing you'd have to do first is to be sure you can understand the message. Why should we expect that beings that are very different, evolved in a different place, different period of time for their evolution, should be able to send us a message that we can understand? And the reason I think that's likely is that they live in the same universe as we. They must deal with the same laws of physics and chemistry and astronomy as we. To test the idea that a signal could be understood, we did a little experiment. We can only use human beings. It's too bad. I wish we could use some other intelligent beings to make such an experiment, but we're restricted to people. They're the only ones we know about. And so what we did was to devise a complicated message, which you can see here, of zeros and ones. The 0 and 1 might be a long and a short radio beep, you know, beep, 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 beep. Or it might be two frequencies, beep, 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 beep. Might be many things, but it's a language of two letters. And you can see there's an enormous number of zeros and ones, in fact, 27,000 and something of them here. You can't tell just by looking at it, oh my goodness, I see what this is. You have to think about it. Now the key to this is that the total number of zeros and ones is 31 times 31 times 31. 31 cubed. And it suggests that it's a pictorial message in 3 dimensions. And if we were to write it in a sequence of 31 symbols, then go to the next line, then you see it starts getting a remarkable regularity. And so what we did is to give this message, not made simple in that way, to some graduate students of mine at Cornell University. They were told nothing about what was in it, how to decode it, and their job was to figure out what it said. And here they are describing the process they went through to figure out what the message was about. These are all graduate students of mine who are reasonably clever. But none of them work on this particular problem.
Well, we gathered together in the Mars room and stared at it and cursed volubly at length. Kathy noticed that 31 divided into 29,791. And it was determined that the remainder, 961, was 31 squared, which left us with a 31 by 31 by 31 sequence. And then we sat together, 6 of us, for 4 hours, transcribing zeros and ones, screaming and shouting from one office to the next, and complaining about the typographical errors until we could get the sequence, which is shown in frames there.
They were making good progress. They found some errors in the transcription of this that the BBC had made, in fact, but they figured out how to get around that.
It was not necessarily a three-dimensional model at first. It could have been a movie, because what we see, what eventually turned out to be the corner markers of the cube and the lines which drew the pattern of the cube could have been just frame markers for a movie or a slideshow. It could have been separate frames. And it was only when we had drawn them out and looked at them that it became very uncertain whether it was anything like that.
Since it was a dull movie, you figured it was really a three-dimensional.
That was about the size of it.
So here we have some plexiglass things. So a 1 will be represented by a black square and a 0 by a transparent square. Here's a whole sequence of transparent squares. That is, this would represent a sequence of zeros. Now, building up as the message requires, first space is a 1, which is black. Second space, another 1, which is black. Third space, another 1, which is black. And in fact, it's black 1s all the way across the top line. So the top line there is a sequence of black 1s. Next line begins with a black 1, but then there's a sequence of zeros represented by the transparent markers, and then a 1 at the end. Now we have the similar pattern building up. Black edge, transparent interior, which goes for a number of lines further. Now the next line is different. It starts out with a 1, has a sequence of zeros, and then there are 3 1s in the middle, then the same sequence of zeros, and then a 1. So here is the black 1 at the periphery. Then here are the zeros. Next are the 3 black 1s, and then there will be zeros and a black 1 there. And the remainder of this frame fills in like this. So we now see the picture is a black border and a kind of Maltese cross in the middle, and everything else blank. There are many other layers, and when we build them all up, we result in a pattern, which we will shortly see, and that is the answer. We can tell this is the right answer because of how regular the geometry is. We couldn't have gotten that by accident. So here is, in 3 dimensions, what the resulting model is like. Now let's see what the graduate students have to say about their interpretation of this funny-looking message.
Well, the first thing that came out of our analysis of that object was that in profile it was strongly reminiscent of Mickey Mouse. And in fact, it's still not clear whether that's the case or not. And although we know that you have a sense of humor, Mickey Mouse was not our idea of a joke, so it had to be something else.
The only thing it really looked like was a molecular orbital type drawing of a molecule. And the first one that came to my mind was formaldehyde.
And Kathy is in fact right. This was intended to be a formaldehyde molecule, although it does look a little bit like Mickey Mouse, in which there's a carbon atom, 2 hydrogens, and an oxygen. Now, what could the significance of that be? Why go to all this trouble to simply say formaldehyde? And the answer is that formaldehyde has a radio frequency attached to it. And what all of this trouble is about is the message is saying, don't listen on this station. This isn't the station that's interesting. Listen on the formaldehyde station, and that's where the Encyclopedia Galactica will be. So as soon as we get that message, quick, we turn the frequency of our radio telescope to the formaldehyde frequency, continue to look at the same star we're looking at, and then hopefully get such a message. That's the general kind of idea. Notice that if we made a serious such search and succeeded, the results would be inestimable. We will have ended the isolation of mankind from the rest of the universe forever. If we made a serious search and failed, we would have determined something of the uniqueness, fragility, preciousness of human beings. And it seems to me either way we win.